Good morning. This is the third part of our video series for second block, and we are going to finish what we started on video, or what we ended video 2 with, which is how to do the Chebychev inequality rule. And basically Chebychev is giving us a worst case scenario. He is saying that any distribution whatsoever should fit into his inequality rule, and that is that he guarantees that there won't be any data within one standard deviation, 75% of the data will be within 2 standard deviations, and so on and so forth. So we are going to see how our data of the unemployment rates for the states match up to Chebychev's inequality rule. So the first thing we need to do is take our mean and our standard deviation. And for the mean, we're going to use 4.9. Rounded to 2 places correctly, it'd be 4.90. And our standard deviation, and I should use an X bar for this, I suppose, since it's it's the whole population. So we will use mu, which is 4.90, and my standard deviation is 0.98 that we're going to be using in the S of X. Okay, so we have to find what is the range for one standard deviation, or the mean, give or take 1 standard deviation. So if I put that into my calculator, I get 4.9 plus 0.98, and that is an upper range of 5.88. And if I subtract 4.9 minus 0.98, that is a lower range of 3.92. So I need to look for the data that is inbound by these positions. So I need to find my positions in my data set. So I go back to my calculator, and I am going to go to the beginning of the data. I have to be 3.92 or greater. So that will start at 3.9 is not greater than 3.92, so I have to go up to this, which is position 8. Number 4, the 4 is position 8, so I'm going from position 4, and then I have to be at or less than 5.88. That's what the inbounding is. So if we go down here to find the 5.88 or less, it would be that position, number 42, and I'm getting the position number from right here on my calculator. All right, and going back to my data set, that was position 42, I believe. Now, how many positions are there between position 4 and position 42? Well, to figure that out, we do 42 minus 4 plus 1. And the whole plus 1 thing we discussed a little bit not too long ago. If that's still confusing you why we have to add 1 on, we will try to clear that up for you tomorrow. So 42 minus 4 plus 1 is 39 out of 50 data spots. And I know there's 50 pieces of data because that's what my n is equal to. And if we turn that into a decimal, we get 78% of my data is within 1 standard deviation, and that super exceeds Chebychev's inequality rule. So we're way better off at the start. Now we're going to do 2 standard deviations, and I am going to try to move this up a little bit. Oops, that's not going to work. So if I make this a little bit smaller, I can move those up here so I have some room to work. Okay, so what is my bounds? Well, if we do 4.9 minus 2 times 0.98, I get 2.94 as my lower bound, and 4.9 plus 2 times 0.98 is 6.86. Now I have to go back to my data and look for my positions again. So I will go back to the calculator, and I have to be less than 6.86, equal to or less than that. So 6.86 would be right on that one. That's position 48. And then I have to be at or greater than 2.94. So if I keep going here, 2.94 being at or greater than that, that's position 2. So how many positions are there from 2 to 48? Well, again, I'm going to do 48 minus 2 plus 1. That will be 47 positions out of 50. And changing that into a decimal, you would get 94%. Chebychev guarantees 75. We have better than Chebychev. We're at 94. Again, we have super exceeded his rule. And then finally, to test the third standard deviation, 4.9 plus or minus 3 times 0.98. The low bound there would be 4.9 minus 3 times 0.98 is 1.96. And I want to go to 4.9 plus 3 times 0.98, and that is 7.84. And now I have to find those positions on my calculator. So again, I'm looking for the positions of the data. And I am going to go to my calculator. I have to be at or greater than 1.96, and that is position 1. So that's position 1. Put little arrows on here so people know what I'm doing. Okay, and then the 7.84, if we go up to the top, yep, everybody's inside there. That's position 50. And now you can understand why we have to do the add one. If we take 50 minus 1, that's 49 positions, but we know we have all of our data. So that's 50 out of 50 data points are within 3 standard deviations of our mean. That's 100% of our data. Again, we have overachieved and super exceeded Chebychev's inequality rule. So what is my conclusion? The data set of state unemployment rates and I believe this is in 2005, exceeds Chebychev's inequality rule. And why did that happen? Well, if we go look at the very beginning of our worksheet, we can see that we declared that this data set was, especially by looking at the box plot right here, almost perfectly symmetric, or at least very close to being a nice, perfect symmetric shape. So we are going to say it exceeds the rule, and we would say the data is bell-shaped. And that's why it beat Chebychev this time. Okay, please continue and practice your next worksheet with the darts. For this worksheet, basically what we're doing is we are trying to, if your dart is this blue dart coming in here, measurements were taken as how far away you are from the bullseye, and those are the things that are being recorded or the data pieces that you have in the list called darts. So please continue with a partner doing and examining the darts data, and you can then check your answers with the class slides. Thank you, and be sure to do your homework tonight. Don't forget we have a notes quiz tomorrow morning.